sound things. Now it still says preview. Hey, are we working?
Yeah, we are. Now it's on. Okay, so...
Oh my God, that's it. I'm never doing this again. That's too hard. Are we working?
Okay, so don't say you're never doing it again.
Oh my God, that's it. I'm never doing this again. You got to turn yours down though.
I do. You're hearing us twice. There, I muted.
Hello,
my
everybody.
Hi, everyone.
We're computer engineers. we used a steak knife to fix it this time.
We actually know hardware really well, and the people that write things like YouTube are software people. And
I wrote very little of the YouTube software. Yes. Matter of fact, Microsoft won't let me write software either.
Why is that?
They don't trust me. Yeah, cease and desist, all that. No,
seriously?
I'm a hardware engineer. I can't. I don't work for Microsoft. Actually,
you're beloved by many people, and you seem to have so many others out to get you legally. What the heck?
So, no, actually, a friend of mine did work for Microsoft Hardware, and he was on the Xbox team. He helped work on the original SD-RAMs.
Yep.
So,
as I recall,
go ahead.
There were some people who were previously customers of mine there as well.
Okay.
So, but, you know, every EDA tool vendor wants to argue that they have all those big name brand customers. Truth is, there's a bit of everything in every one of those places.
That's right.
It might only be one seat. And when you have the software that an engineer can actually pull out his company credit card and just get it for himself and ask for forgiveness later, that's what happens.
Right.
So, you know, but if you want a copy of, you know, some high-end signal integrity analysis software, you're going to have to push that one up through the chains of command and request even bean counters have to get involved to sign off on those checks. Yeah. Or you could just do it yourself using Octave. You could just do it yourself using Octave. But anyway.
I was going to say, yeah, there's no putting a key site on a credit card here.
No. No. So I have to say, though, I've been looking at some of those signal integrity analysis tools lately, and although most of them have user interfaces that look like they're stuck in 1993, well, 1995, let's be honest, Windows 95 style UIs, the breadth and depth of capability in some of them is actually pretty incredible.
Yeah.
And they put a lot of research and effort into building them.
So and they were efficient too.
It's no wonder.
Had to be efficient.
It's no wonder that the license costs are so high. So anyway, Bill, sorry, I'm going.
Somebody likes your guitars, man. Oh, yeah, he's your friend there, Wes AD761.
Yeah.
Hi, Chris. Hi, Mike.
Thank you. Thanks for joining, guys. Yes, I love guitars. I've been playing this old Yamaha lately. This one is actually not an expensive guitar. It's what we call a super strat or fat strat, and it's actually from about 1985. So it's old, and it plays like butter. It's amazing. The tremolo, I'm going to replace with a Floyd Rose. But for those who know about guitars, you know what that means. But everything else about it, the active pickups sound amazing.
Well, we pronounce it tremolo. Or bender.
Isn't that what I said?
You said tremolo. It's different in accent. No, I just went to find my guitar. I've got a Mexican Strat around here somewhere with EMC pickups. Again, doesn't sound anything like it did when I had all my fingers.
Oh, but those actually, you know, I know a lot of players who have those Mexican Fender Strats, and they say with a good setup, they're just as good as the USA, and you know, won't break the bank, but you can then mess around and change the pickups and mess around with
exactly what I did
without worrying too much about breaking anything, because it's not a $2,000 guitar. Yeah.
Right. So, yeah.
Yeah.
So anyway, what do you want to talk about today?
Well, we weren't going to talk about guitars, were we? We were going to you had some things and I had some things, but I wanted to ask you actually, Bill, because you've been at this for longer than me, and you've done a lot of really interesting stuff, and that's why everyone wants to listen to. Everyone stops and listens when you talk, right?
It's because I make it up.
Which is part of the skill set. No, but I want to
BS
ask
on
you,
demand.
like, you are a contract electronics engineer. You take time out of your busy schedule to talk to me and do this stream, and you do various other things. You do a lot with Hackaday, and I guess that's part of your marketing strategy as a contractor. But just for myself, and also for any of these guys who would be listening to us, how do you make it as a contract design engineer and PCB designer?
The first thing I tell you is you almost need a company of two. To stop and do your own accounting or even your own sales can be hard. So a lot of people I know that succeeded had two people in the company. In my case,
like
I had
their wife.
Yeah.
Or them and their husband, or significant other, I should say.
Which works for accounting, but for sales, unless your wife is into sales and goes out and sales you as an engineer, right? So as a contract engineer, you're either doing the work or you're looking for the work or you're trying to do both at once. And it gets hard to do both at once because you want to put your head down and work on what you're working on. So what I had the luxury of doing is I had a huge overlap. I had a couple years to build my customer base in the background. So that's, it's kind of like don't start until you don't need the money. I hate to say it that way. Or latch onto a big job to get you going.
Ah, right. So basically leverage the contacts you have.
Networking, yeah.
And be disciplined financially so you can build up a kind of
coast. I have a 3 to 4 months. Somebody's already talked about being paid. If I required my customers to pay on time, I'd be broke. They want to be polite. They do the best they can. But at the end of the day, I'd better have a couple months of buffer also. Just normal. It's like being an actor, I imagine, where you don't know when your next acting job's coming.
Yeah, well, then that leads to another question. Actors who actually get jobs charge an exorbitant fee. And
for the downtime, you have to.
Partly for that very reason, but also because they're famous and in demand. So like it's a double whammy. If you're good at what you do, it can really take off no matter what industry you're in, I guess, right?
Yeah.
Unless there's absolutely no demand for your skill. I mean, there's no point being the best art historian in the Southwest if there's no jobs for art historians.
Right.
But,
so the other thing is
how do you decide what to quote people and charge them? Because
I was just getting ready to say you only take home about a third of the money by the time you're done. At least here in Jersey, by the time I'm paying insurance, taxes, I do recommend you become a company, not do it just personally. But I'm an LLC. You're an LLC also, right? Limited Liability Corp.
I actually have a California S corporation, and if I'd have listened to better advice way back, I'd be an LLC. Yes.
I've had both an S chapter and a regular C chapter, and yes, I like the LLC a lot more.
Now, why is that? Why is it better to be an LLC? I have my own ideas, but they're not based on personal.
Well, in theory, there's a better veil, the corporate veil that protects you from being sued. You got to make sure that whenever you sign your name, you say by Ben Jordan, manager, CEO, or by Ben Jordan, member. As long as that word by is in there, you're speaking on behalf of the company. But if you sign it Ben Jordan, you signed it personally. So if you sign a contract Ben Jordan, you're on the hook personally in theory.
Right. So
that's one of the major things about it. LLCs also get a tax break. You only get taxed once. You get taxed on your income.
So that's if you treat it as an S to be treated as an S. It's an LLE being treated as an S corporation, right?
And so I don't even take a salary. I just take more like bonuses. I just take dividends. So because I don't have a salary, I don't have payroll taxes and that thing where you hurt yourself on site, whatever that's called.
Yeah. So that was the advice. And Chris, you're quoting the same thing. That's exactly why I set up an S corp several years ago. That was the advice given to me by a tax attorney here in California.
Right.
But I have a lot of extra paperwork to do with an S corporation. And I have to pay at least an additional $800 a year just for the privilege here in California because, hey, it's California.
Yeah,
and
I do the same.
Yeah.
Jersey's like a baby California out here when it comes to taxation and whatnot. So,
well, a baby bear is a lot easier to handle than the mama bear.
If you're holding a baby bear, you should be looking for the mama bear. That's yeah. Somebody just mentioned Jersey taxes compared to Pennsylvania. Yep.
Right.
So, and it only costs you 5 minutes to drive from Jersey to Pennsylvania on the bridge. Coming back's free, but $5 to actually leave the state.
Oh, that's crazy.
Yeah,
crazy.
I couldn't afford to stay here after I retire. So just like I couldn't afford to live in San Diego, when I retire.
The latest talk here in California is they're voting or the California state legislators are trying to bring in a rule to penalize wealthy people for leaving California. Because everyone's just started leaving. All the conservative
New York's doing the same thing. Yeah,
are leaving, and so instead of fixing their bad management of the state or undoing the things that are causing people to want to leave, they're just saying, no, we'll bring in a law that says we can tax you for 10 years after you've left. So everyone's leaving even faster before that law comes in.
But I died. Well, we're taxing your estate.
So I don't get how, unless it's for a prior year where that was your residence for tax reasons, how can it possibly be allowed or legal?
I don't know.
Stand for this. It just makes no. It's like me saying, well, I used to work at Altium, so Altium has to keep paying me. And having the governmental power to wield to force that to actually happen is kind of just. I don't understand how the federal government can't stop that kind of nonsense. But anyway.
So to change topics,
if I legitimately owed them, sure, yeah, I should pay them what I owe them. I get that. That I agree with. But anyway, okay. So that's nothing to do with electronics. Sorry, but
no, but actually, then we can talk more. Later as we talk more about the business and how do you do other things as a small business. We can certainly pick those up in future shows. So. Hey, so I got a question for you. Where do you buy obscure parts? Do you have a favorite source?
And this shows how narrow my work currently is as far as actual design and build goes. But I honestly buy a lot of parts off AliExpress, it's dodgy.
How long does it take to arrive?
At the moment, it's painfully slow, so I actually end up going to Mauser and DigiKey for most things, like most of us do, right?
I used DigiKey in the 80s when the catalog was only that thick.
There's a few places. Of course, I do use aggregators, search aggregators like Find Chips, and there's a bunch of those around now.
Find Chips, that's actually Matt's, isn't it?
Well, that's Supply Frame, and I want to actually do something there. I think we have a lot of opportunity to do something there, and solve some problems for finding parts. At the moment, there's a lot of ways. Even just Amazon and Google seem to get results pretty good now, but
But they won't make a footprint for you, Amazon and Google.
No, and so that's where tools like
EDA CAD.
Library.io,
Yeah.
Snap EDA
Yeah.
is another one that you can do that. And of course, every CAD vendor has its thing. But I love to use this. At least when I was or am or whatever designing with Altium, I really love to use the Celestial parts library. So that's not finding parts to purchase, but it's an extremely high quality library for models, for symbols and footprints.
Right. Right.
It's
though I've gotten a lot of problems out of there. I probably run about a 20% rate of bad symbols coming out of EDA CAD, or I mean Snap EDA.
Oh, really?
Yeah.
Because I thought they were community verified, kind of like the EE concierge concept as well was like that,
Yeah.
where multiple people had to agree that it was good, and then that's when it got made available to people.
Yeah, no, I've seen, and some of the errors are just that layers aren't all the same layers, and other times I've seen a circle not be a circle. What should have been. So it's like everything. It's a convenience to get the part, but it's still on the designer to verify the part. And I could pound the table on that one. So,
yeah.
and by that I mean you look at every pin, make sure pin 1's pin 1, pin 2. I had a part that was 90 degrees rotated about 3.5 years ago, and it was a little tiny ESD protection device for USB. And son of a gun, if it didn't come out a Snap EDA with pin 2 on the corner, and I missed it. It was a 4-pin part. And it was.
You never really know the original source of
That's
these.
right.
I discovered because there's another one called Ultra Librarian, which many of you would have heard of.
I keep that on my desktop, actually.
And it's been around probably the longest as far as a vendor neutral sort of CAD generator. But they came up with an XML style format that allowed easy software to be written around it to put everything in this sort of it's called BXL. And then it allows them to take symbols and footprints from any CAD tool and generate them from their database in any CAD tool. And big semiconductor companies standardized on that BXL internally and using Ultra Librarian, and then writing their own connections to all the different CAD tools that they want to support on their websites.
Right.
But some of those footprints, for example, would have originally been in, say, the Altium Vault, and then brought across, and then as a result of that, made available to outsiders in other formats through Ultra Librarian.
Right.
And that also may have fed into Snap EDA. So I mean, it's a very small, close-knit industry, and whatever you can do to save time and effort creating content, you do, and that means downloading it from semiconductor websites and doing translations on it. It means all sorts of things. But there's one open source library I was talking about is called the Celestial Library. It's run by a guy out of the UK called Mark Harris. And the cool thing about it is it's open source. So he manages it. He's kind of like the product manager and lead developer of it. But anyone can contribute a part, but it's all done through GitHub and pull requests. So it has to be approved before it gets added in. And there's many tens of thousands of parts in there, and they're all very high quality and have good step models and everything. I'm hoping that I can somehow get access to that and work with Mark to do something for Fusion as well, because it's a very, very high quality library. But coming back to your original question, where to find obscure parts, I know some of the guys on the chat there, or people on the chat there, are saying, like Chris, you've got all those NOS vacuum tubes. What are you going to do with those? I mean, I like vacuum tubes. I'm a guitarist. To me, vacuum tubes are for high gain preamps. And
did your TV set when you were young, did it use vacuum tubes?
When I was really little, the old TV that died shortly thereafter and got replaced had some tubes in it.
Yeah, I had a tube TV set into my 30s.
Wow. See,
So, yeah.
see some of those things. If you're not moving them around, they last a very long time.
Oh, I loved them. I loved an old Xena TV set, and so every time it would finally break, I'd go get another one. And I had picked Zenith. I used to be a TV repairman at the age of 17, and Zenith turned into my brand. That was the one where you go, even though my dad worked for RCA, I didn't like the SKS chassis. I was like, SK chassis. Give me a Zenith. So, and then there was the Quasar works in a drawer. Oh, that was I don't know if you remember those commercials, but they were, they sold a TV set based on how easy it was to service, because if you owned a TV back then, you would have to have a TV repairman every 2 to 3 years. Yeah. So there was tube testers in stores, and they weren't really tube testers. They were filament testers, things like that. But sure enough, you'd load up a box of tubes and go down the drugstore and test them.
Yeah. So now, there's still those. I still think that the two primary uses of tubes, and they ought to still be manufactured for these two things. And one is obviously audio and musical amplification.
There's RF power.
But there's only a very narrow set of tubes really made for that are just so good at that there's no need to make tons of different types. And then the other is high power transmitters.
Yep, that's why I just
said. You can't do that. You just can't build a MOSFET to do high voltage, high power.
Right.
It's just not going to happen. If you want anything more than a couple thousand watts, you need a tube.
I used to hang around a radio station. I used to hang around a radio station when I was a kid, 16. And there was one big cabinet, and they would open the doors and show you, and you'd see the big tubes in there, and you'd see the secondary radiation coming off in pulses to the AM radio signal going out. And I remember one night they did, how they do the test, the following is a test of the National Broadcast Association, and they turn off the carrier for 30 seconds and then on and off. They did that, and the carrier never came back on. So they had a plane specifically fly from like Ohio, bringing this tube and the insulated socket for it so we could get the radio transmitter back on the air.
Ouch.
Yeah, but that's all it was. They turned it off, on, off, dead. And so imagine you're at home going, this is only a test, and then the station drops off the air, right? Or you hear the sound of a phone melting or something like that.
Actually, that's another good question. Like there are certain tests that you kind of might not want to do because it's like with an old car engine. Once you get this thing started, you don't want to turn it off because you might not get it started again. So,
especially in cold. Hey, so on the subject of the 80s and radio stations and stuff, I got an obscure piece of electronics I want to show you. What is this? It's got a cord. It's got a handle. It's got a button.
Wait, I got to enlarge my Skype view there so I can.
Somebody guessed.
What the heck is that? I've got
That's
no idea.
That's a Degausser. That's actually it's a bulk eraser or a Degausser.
Yep.
So remember tape? Remember that was the only thing we could store crap on? And the way to get a better recording was to do a better erasure on the tape. And so
because it's like leveling a battery pack. You've got to completely reset all the
bias of all the molecules on the tape. Yeah. Now the radio station I hung around had one of these built into the desktop, and one time the guy hit the button by accident while there was a phone on it, and the phone jumped off the table. It was actually pretty funny. But can you imagine how dangerous this is to have laying around my lab? It's a magnet that throws off, a huge field. So it's going back on the floor. So I just figured I'd show you that. Do you have any obscure electronics? Anything worth talking about?
Not today. I did some time ago, and we talked about this months ago when we were streaming. I did get myself a high pot tester, and I was going to get some cheap Chinese power supplies, which are designed for driving LEDs, industrial lighting. So they're kind of open frame-ish. They've got metal enclosures, but they're designed to be inside a cabinet in a building driving LED strings, right? And they absolutely, if I show you the PCB, they absolutely do not have the creepage and clearance you would expect
for those voltages. Yeah.
Well, it's okay if it tests right, and if it's intended for an industrial application where humans aren't going to go close to the secondary. Even though the secondary is isolated, at first it looked like it wasn't because there's no opto isolators for feedback, and then I realized it's using magnetic feedback. It's pretty clever design, actually. So we could do that in a live stream sometime. It'll take me a little bit of effort to get all that set up clear the bench so I can get it all there, but I think we should do that.
So those supplies, are they marked CE, or how are they marked?
Oh, yeah.
Because I know you've got a thing about that.
They're marked CE. I think a lot of things are marked CE just because it seems to be trendy to mark the thing CE.
It comes with the case. Yeah, it's already stamped on the housing.
Yeah, I think it actually doesn't mean anything in many cases.
Right.
Like, I doubt these have actually been to a lab that really has certified them. They've probably done testing to make sure they're safe in the factory, and they have their own standards that they run to, which, I think they love their children just like we do. So they do make things safe when they want to.
Nobody says they use the same one at home, though.
Well, it's also a balance of cost, and it's the intended application. These things are LED lighting power supplies, so they're not meant to be anywhere accessible by human hands.
Right.
They're meant to drive strings up on a roof somewhere, and so they don't have to follow all the same regulations, but I believe they're not actually certified. I could be wrong.
So how much familiarity do you have with UL, then, the Underwriters Laboratory?
I've never had the how do I say this? Never had the pleasure of having to push something through that process. I've worked with a good friend of mine, Chris Carlson, who was in most of his career was in power electronics and industrial drive systems and motor controls, and they had to run everything through UL. And he said his favorite is the dropping flame test, where you actually light a piece of plastic on fire so it's got dripping flames. Like, I'm sure you've done that before.
We call those zilts because they go zilt, zilt.
Yeah. I got a zilt on my leg once when I was a kid.
Oh, yeah. Yeah, that'll leave a scar.
It kept burning. I've still got... Actually, I think the mark after 40 years has gone away, but...
We had some white phosphorus come down on our gunnery range one time, and it's the same thing. If that gets on you, it just keeps burning. And we all decided to go that way, because the rounds were landing that way. So, hey, now I have used UL, or done UL. Yeah. And what's surprising about it is it's voluntary, sort of, right? You don't need UL to make something, but you need it to sell it, at least in my day, in certain cities. So like Chicago, home of UL, you had to be UL underwritten to plug into inside a business inside city limits. Same with Los Angeles. So what it was enough big cities required you to be a UL listed that, if I was doing a consumer product, you just went and got your UL listing. And you're absolutely right about voltages in a power supply. Part of UL is, are you above 48 volts or below it? Okay, if you're above it, do you have the spacing you need? And they'll tell you you need a certain width, certain spacing on your PC boards.
Yeah.
So, yep.
Yeah.
Hey, let's talk about hard stuff like wettable flank parts. Have you
I have never used those.
Well, I want to try and show them. Let's see if I can. By the way, underwriters used to throw safes down their elevator shaft. That's the original underwriting of safes, was where they could withstand a drop test. Hey, can you share your screen? I'm set up to see a shared screen. Can you share your screen with the link to wettable flank parts? Because that sounds ominous, but they just make so much sense.
Do you have a wettable flank, Bill?
I do. It's in the show notes. It's just I'm not set up to share your screen without.
Wettable flank part. Sounds like something. Sounds like cuts that I would use for grilling.
Yeah. What it is the. Well, let's get a picture of it while you're doing that. But the main thing for me about wettable flank parts is they make these parts.
It's like DFN, basically.
It is, but with an outside edge that you can put a scope probe on. But then for me, since I do home soldering, home building of SMD parts, it helps me align the part to see the pad itself. There we go.
So this is on DigiKey's forum.
Yep.
So I call that a DFN, right?
Okay.
But I guess they have this. The typical DFN has essentially only the lead frame thickness machined off on the side of the plastic molding.
Whereas right. Can you scroll down just a little?
It looks like the wettable flank is a DFN with a bit more metal up the side of the part.
So what that means is when you're hand placing the part, not using a pick and place machine, you can see the pads you're trying to line up with. So if given a choice of this or not, I tend to use this kind of part. So it was just one of those things that came up this week. The other thing is it gives you test points. Now there is that little external thing instead of being buried up under the chip. By the way, your cat is back.
I know. I got a notification on my phone again. And
oh, I should sit there and do that. I should beep your phone.
Oh, dang it. I think it's connected to the wrong computer now.
So while you're talking, that's actually not a bad segue into soldering yourself. Have you ever flipped them on and placed them in a cutout in the board? No, I have not. Have you, Chris? Ever flipped a chip? And now we used to do flip chips in the old days. We used to do die on board. Oh, I love die on board. In die on board, what you'll see is where they'll actually take the die after they break it off the wafer, and instead of putting it into an IC package, they flip it over and solder it directly to a PC board substrate, and then they put a glob of goop on it to protect it. So if you've ever seen, particularly an LCD display, and you see a gob of goop and a bunch of traces running on there, sometimes it's not even a chip under there, it's just a die, what we call a chip, meaning the housing. It's a die soldered directly to the board. And you just have to remember that when you flip it over, everything's opposite of each other.
So chip on board or...
chip on board was where I ended up talking about
embedded. So have you actually looked at who can do embedded components? There's a few companies around the place that have sort of chosen to specialize in that. I think Electronic in Europe had a whole
blog on board.
Electronic had a really nice document you can download that it at least highlights their process and how they do it. I think it's still such an exotic early days kind of thing that that most PCB fabs have a kind of non-standard or their own particular process way of doing it. But one of the things I was looking at was this stuff called Ormet paste. The guys from Inselectro have been talking about it a lot. PCB designers have been talking about it a lot. It's a paste of conductive. It's not solder paste, but it's a proprietary blend of metals, and they use it in between layers in lamination. So instead of doing plated through-hole vias, they actually use this paste through holes. So they have unplated holes, and they squeegee this Ormet paste on, and then in the lamination process of the board, I'm probably butchering this, but the heat and pressure of the lamination press actually causes a sintering process to happen in the paste to make it essentially a solid conductor.
Right.
But they can do tiny little connections, like 1 mil wide, and but what this also enables is that belly up flip chip embedded active components in your board. So you can actually have a cavity, and you can put the chips in the cavity.
Yeah.
With their pads facing up, essentially, and you can Ormet paste over where their pads are through the next layer of dielectric, and that forms your bond into that component inside the board stack up, which I think is pretty awesome.
That sounds like a mass quantity technique also for the amount of prep time and cost.
Yeah.
So that's,
I guess,
yeah, but when you're after every penny, because a penny times a million is a lot of pennies.
Yeah, it is. But and at first, like, it's the cell phone industry that drives all this stuff, right? So embedded active components.
That's a good point. Yeah.
Samsung did it for it was the S6. It might have even been as far back as the S4 had embedded chips in the actual PCB for some of it, just to get it to fit the profile of the case.
Right.
But they're making, millions and millions of the
Right,
devices. Right. And so this technology is completely out of reach. But what I love about this industry is eventually we get everything, because some clever person
finds a way to standardize it.
Yeah, or they make a machine that can sort of automate it for low
right.
volume production as well. And
now that was a real interesting comment about the cell phone industry. Would you say a cell phone is driving HDI, the high density interconnect stuff, as well?
Absolutely. And you were at Altium Live speaking the year.
Yep.
I think that Happy Holden was there as well.
He was there. Yep.
He's called the father of HDI, right? So he kind of was the technologist who pushed that. But at the time he was doing that, he was the CTO for the PCB manufacturing division of Foxconn. And Foxconn was the contractor, and I guess still is, but I don't know. But at that time was the contractor that Apple partnered with for their motherboards and phone PCBs.
I know he told me Wozniak used to work for him, was one of the things we talked about that night. I let it go. I didn't tell him who I was.
Wozniak.
Hey, so solder paste, right?
Yeah.
If you get a chance, can you bring up a solder paste profile, the heat profile versus time? But what I wanted to talk about is
it in this blog?
No.
Let me bring this up. So what kind of solder paste? Lead or lead free?
Oh, any.
Go lead free solder.
And we can talk about the difference.
Profile. Do you want the temperature profile?
Yes.
Just the normal profile that you do with your oven.
Right. Because my question is going to be, why not just stick something in an oven and turn the temperature on full? Why that doesn't work? Ooh, I like that green and white one there.
This one? Yeah, let's bring that up. That's cool. I wonder if I could. Yeah, here we go.
All right, so that's not just turning on an oven and letting it soak. What's going on here?
Well, you got to warm up the whole thing to. There's a number of things. The preheat stage heats up the whole board and helps the whole thing even out,
Right.
and boils off moisture that would otherwise damage everything.
Okay.
So
Okay.
if there's moisture, because moisture gets into the sides of your PCB, and moisture gets into some of the components, and ideally, that's why everyone knows this, right? That's why they're delivered in sealed bags with the beads,
Moisture indicators. Yeah.
yeah, and moisture indicators. And if you leave them unpackaged properly for a while, you got to, or even in that case, you still got to
Though
bake
it's
them.
rare for home users to have a problem with that.
Yeah,
That's more for mass production, and the problem we used to have was moisture actually getting infiltrating the epoxy resin package, like along where the leads come out of the package. It'll capillary in, and then
and the
it
same
can
thing happens with the glass
outgas
and
or
the
expand
PCB.
or something.
Yeah,
Yeah,
yeah.
right.
So,
So here's the thing: solder paste though isn't just solder. What else is in there besides little blobs of solder?
well, it's flux,
Flux,
or water.
right?
A lot of
Right.
pastes are water based, so you've got to boil all that out.
And so that's really the answer where I was getting at why you don't just shove it in the oven is you'll if the temperature is just high and just not coordinated, it'll just boil off the flux and then you're just left with little globules of solder and they're not going to solder. They're going to just be a cold joint at best. So you do the pre-soak, but not forever. You do it long enough. But if you were to pre-soak for like an hour, you boil off all your flux. Is that a
Right,
fair
but
statement?
then you would, but then you might also damage components. So you have
The
to
fair
limit.
point.
You have to limit the time. If you look at every component data sheet has safe handling instructions tables, and part of that is storage temperature, and they also have the operation temperature. And we tend to think about the maximum operating temperature. There's a maximum storage temperature, and it's usually well below. It's usually 150.
Yeah.
Like well below 150 C, well below soldering temperature. And then some of them even go so far as to specify
Humidity.
peak soldering temperature allowed,
Right.
which can be a problem because you'll have incompatible parts. If you have a big set of D-packs or MOSFETs, right down on the board, and you need a lot of heat to get them to stick, and you got a lot of copper in the board, and then you have this one delicate part off in the corner where the manufacturer says you can't heat this past 260 degrees for more than 10 seconds. It's like, wow.
And then when there's a big part, there's a shadow around it too, right?
Yeah, yeah.
So a big part, you don't want to shove little tiny parts right up next to it unless you really, really know what you're doing.
Yeah. Oh, where's 8761's asking where did MOSTech get their boards fabbed?
Japan. That was the China of the day. K-tron, we pronounced it.
Right. Yeah.
So
well, only it wasn't too, because Japanese, everything they made was so precise, and still is to this day. And I'm not saying China doesn't know. China knows how to make good stuff. Let's be honest.
right, but they're in the business of affordable items.
But even back then, Japanese made devices were exceptionally high quality.
Right.
Exceptional. That's why I like these Yamaha guitars,
Right.
So
right.
anyway.
So did you ever see this from my little oven?
Yeah. I haven't seen it in operation yet. Is it functioning now?
Oh, fully functional. My son's made 3 of them. I've sold 2 of them to friends. And actually, true to form, it just cut my finger on the bottom. So the thing is, yeah. But no, this uses a Control Leo 3 and does a pretty good job of actually not cooking off the flux. So
Cool.
I've been getting, and it's got a leaded profile, which I haven't used myself yet.
Does it have
here's the other thing.
Does the Control Leo 3 use a graphical display?
It does.
Does it show you the profile?
It does, and it shows you where you're at on the profile.
Oh, that's cool. That's
Yeah,
cool.
yeah,
So
I love that.
That was the other thing. The early versions of that just had a character LCD, which is fine.
Right.
But when I went to China and saw the 968A engine desktop oven that I've got, it had, graphical display and multiple memories for profiles, and it was
Right.
really configurable, so I liked it.
Now,
Yeah,
the
but anyway.
Chinese one from Aoyue, however they say it, 892 or what it is, you've seen it. It's the real common one with a little slide-out drawer for the...
that's the smaller version of the one I got. Yeah.
Right. So the problem with that, though, that smaller one at least, is it's an infrared heater. And so it will turn dark components darker because it heats by radiation. But the spec for surface mount is it's supposed to heat the air. Yes?
I don't think that's actually the IPC and manufacturing bodies don't dictate either way how you.
I think they dictate you can't use infrared.
I don't think so.
I'll research that for next show.
We'll look into that.
Yeah,
However,
I'll look that up.
What I do know is some of the best ovens, commercial ovens, use a blanket of hot nitrogen.
Yes.
So it's not quite a sealed system, but it's more or less sealed. And they heat directly, but they pass nitrogen in there, so there's no oxygen or other stuff from the atmosphere. And of course, naturally, you think, well, that makes sense. You don't want oxygen there. You don't want to be oxidizing things as you're heating them up, and it helps the flux do its job. So nitrogen's good. I realized
keeps oxides out.
The Mars atmosphere is CO2 mainly, and we used to think, so all you have to do is send a bunch of plants there and plant a forest. Of course, never mind that it's too cold for anything.
Never mind that the iron would absorb the oxygen and make rust out of it.
Well, there's that too, but plants won't function without nitrogen. The world we live in here, that atmosphere that we have is unique, and it's the only thing. It's not the only thing. It's one of many specifically unique things that supports life. That means you can't have life anywhere else unless you have exactly the same
exactly
sort of
the setup. Yeah. Yep.
At least not human life, let's say.
So one thing I wanted to show real quick was here is a tube of solder. This happens to be lead-free solder, but this is how I get mine from Zephyr. What do you call it? He has a name for. That actually says Osh stencils on it. So I got this from Osh stencils.
Yeah, I love those guys.
Yep,
I use them.
And so
they're great.
The recommendation is you store it in the tube. What's that?
Could you give us a demo? Could you demo the machine?
Yeah, I could do that. Not today, but yeah, we could burn. Matter of fact, I owe Hackaday a board on me using my my oven, so maybe I'll do that. But what I was going to say though,
let's do that sometime. Maybe next week.
If you get a small container of paste, like you'll get from SparkFun or from some of the other places, SRA solder, if it's not in a tube and it sits long enough to get a scum on it, throw it away. You're done. So keep it, at least what I do is I keep it stored like this with the plunger in it. That way all the scum and stuff is at the top, and the most workable flux paste mixture is down near the needle.
All right, where do you store it?
I store it in a small refrigerator standing up. I have a refrigerator just for my solder paste.
Yeah.
And given that it's lead and everything, don't stick it in your home refrigerator, please, folks. So here's the other thing that looks blood red, like my finger. That's so here's the question. How do I solder on two sides of a board, Ben? Won't the parts on the bottom just fall off after I flip it over and put parts on the top and I put it in the oven? Won't they just desolder and fall off?
Only if they're super heavy and there's not enough surface tension to hold them there.
So what do you do if they are super heavy or not enough? So surface to. Well, first off, does the solder really reflow a second time? And my answer is not if you're doing it right. So the reflow only happens once. After that, you're just baking a board because the flux is already boiled off. So am I correct in saying if you have a board at 220 or something and you put it in a second time, it's not going to reflow like the first time?
it won't reflow like the first time, but the solder will melt.
It will melt and it'll be ugly. Yeah.
It's a eutectic mixture. It may not be ugly.
Well, if it goes cold.
It could, yeah, you have to be careful. If you're really worried about that, you get a jar of flux with a little brush cap and brush some flux on the bottom before you put it back in.
Here's what we used to do. That's epoxy.
Oh, really?
Yeah, so you can get an epoxy mask like a solder mask, and it glues the parts that go on the bottom. It puts a dot of glue.
Yeah.
Then you put the parts on, and now when you flip it over, even if they're heavy, the glue is, in theory, still holding it to the board. So that's kind of one of the ways we cheat on that.
That's a good way to do it in your home lab. I would do that. It's a lot faster than with a mask. It's a lot faster. And this comes back to libraries. You should think about these things when you're making your libraries and standardize on how you're going to do it. You need a layer that's a glue dot layer. And a lot of people don't bother doing that. They leave it out because they think, it's all just going to be done with a pick and place. And most of the time it is, but just that one time you have to put parts on both sides. And here's the thing. In assembly, I've toured many assembly plants like Worthington Assembly, the one we used to use for nanoboards for Altium in Shanghai. I've been through there, called Suntech, I think. They put the glue dots on that's the very front of the assembly line. They have needles like that syringe you just showed us, Bill, in a machine, and they actually do it really fast with a machine driving the needle like crazy fast.
Like a CNC needle.
Possible.
Yeah.
Yeah. And it's like, and that board's done, and then it goes into the pick and place that puts all the parts on top of that. And then most of those situations that glue dots were needed when the parts were going to go through not a reflow oven, but through wave soldering. Because you have to glue them first with wave soldering, because the solder wave will just suck them away and they'll disappear into the bath of solder.
So wave soldering, for people that don't know, is like the old through-hole method, wave and drag soldering, where people used to say wave solder, but a lot of times they meant drag solder, which is where it goes down and actually sits in a bath and then keeps going. And wave solder is there's actually a fountain of solder and the board goes through the fountain. Yeah. And we used to have to design knowing which direction it's going to go through that machine. So we would be So I actually would pick the edge, pick the direction, put an arrow right on the board if there was any doubt, and actually design for the type of solder machine we were using.
And
it was fun.
And early SOIC and other surface mount parts that had rows of pins. If you put them sideways, they would bridge. If you put them lengthways, they would not, but you'd have to have extra pads on either end to thieve solder away from it to prevent it from creating a dag that would hang off the last pin.
We had names for that, and I can't remember, but we had almost like football names. There were blockers or something that actually would act as that shadow that you're talking about.
Yeah.
So yeah, or make it worse if you did it wrong.
Yeah.
So, well, I know what I was going to say. You mentioned solder mask a second time, and I was just going to show. I always use my solder masks on a frame, and maybe next time I'll show the machine this goes into. But I bolt this to a piece. It drops down onto the solder board, or to the board I'm going to solder. And then I take a squeegee and I put the pages on. And when you're doing the squeegee, the idea isn't to press down real hard and force as much through. It's just like laying a layer of butter on there. So if you put this on here and squeeze too hard, it'll squeeze the paste under and you'll get solder bridges. So it's kind of a technique to learn. But my son can rip through these things. He drops it, lines the boards up, pastes it, and the next one in a couple minutes. So, but that's called a frame. When you get it this way.
Yeah. Cool.
So, all right. Well, we're actually past 1 minute, 2 minute past. What was anything else we wanted to talk about today?
Were there any other questions in the chat that I missed? There probably were.
Yeah, re-question again. How can they wave solder the SMT? Yes, you can. You can go back over and wave solder some through-hole parts, but you better know more than me before you do it. You got to know what you're doing, in other words.
Yeah, most factories now have really fancy selective soldering machines that kind of replaced manual soldering irons. And if you ever get a chance, go to a assembly house and tour it and watch them in action. They're pretty awesome.
Yeah. Yep. So
it's like.
Yep, I'm back. Whoop, you're breaking up. We lost you.
Flux.
Okay, start again. You're back. We lost you for a second.
I was just saying they've replaced it largely with selective soldering, because most of the time you only need one or two components on the board or through hole anymore, and the rest can go through a regular reflow. So that it goes all through reflow, and you can reflow some through hole parts if they can take the temperature. Right. You can actually, I've seen solder mask designs where there's a through-hole component mounted through holes, and the solder mask has pasted a long strip of solder next to where the pin comes out. And then it goes into the reflow oven, and as that whole thing melts, the hole and the pin wick it all up, and you can plan just the right amount of solder. And it's incredible if you do it right. It's really cool. It works well. But the selective soldering machine's the other cool way to do it, and they do that after the reflow oven.
Right.
Just for the parts that need it, they have a little nozzle that comes up with flux and fluxes them, and another nozzle that then comes up and robotically just covers the pins that need it, and does a fantastic job.
What parts might you be tempted to still use through hole on yourself? Because I have a couple parts where I might reach for through hole.
I use a lot, mainly connectors.
That's it, and connectors because they're under pressure, and nothing sucks more than your USB micro connector just coming right off the board.
These things come off so easily. One little yank and they're snapped off.
So when I do that connector you just showed, I put my finger on the top of it and press down to plug in or pull out, because otherwise, unless there's guide pins, and so that's the other thing, is if you are going to do SMT on a connector, look for some kind of mechanical mechanism that holds it in place, and usually they're guide pins, two holes in the board or a hole in the board, and the pin goes through, because then you're pulling on the PC board, not on the traces.
Yeah, and there's others. There's going to be others too, like relays, anything electromechanical, really, and connectors mainly. Some audio electronic semiconductors I will do through hole because.
I missed the TO3 case.
Well, I hate that. Oh my gosh.
I dropped a TO3 one time and it rattled. TO3 for everybody is the oldest, biggest power transistor case, and they were just they were horrible. but they were ubiquitous back then. Them and 6BQ5 you mentioned tubes that are common. 6BQ5, 6J8HA were the audio outputs that I was familiar with.
So
and 6BQ5s.
I've heard of those
6BQ5A.
Look at that. You can still buy them. Look at that.
Yeah, they're
$50.
Oh my God.
That's stupid.
I have some around here somewhere, or a pile of broken glass.
Oh, that's the American name for an EL84. I know those.
Yes, it is. Yes, it is.
Those are commonly available because they're the most popular in Class A guitar amplifiers.
Yeah, yeah.
You get a set of 4 of them. in push-pull with a transformer, biased into Class A. That's the output stage of a Vox AC30, a matchless DC30 or Chieftain, a Fender
BC 30055. Somebody saying.
Yeah, there's BC 3055. I think maybe that's actually a 2N 3055. You're thinking?
Oh,
Rob?
PNP would be 2N 3055. NPN's 3054.
Yeah, you can still get those. But I hate those. Those TO3 packages are the worst thing ever. I mean, they met the need for heatsink back in the day, but man, they are a pest. Oh yeah, and I like this too. There was this trend of tearing them open for a while to check the legitimacy. For a certain power handling, you need a certain surface area.
You do. You have to have that conductive heat channel for it to come out.
With all the fakes.
All right, Wes, the Rev 1 Vic 20 started fires. Okay, it would sag the plastic. It would get so hot, and I know a guy who says that was me. Vic 20 starting fires, my fault. I'm like, you? He goes, my fault. And I have to believe him, because who would say they're the person that did that to the Vic 20? I will say it was a programmer.
Or was it an LM317 mounted to an insufficient heatsink?
LM317s didn't exist back then.
Or what was it? Was it just a transistor used as a regulator?
No, it was a 7805.
Oh, so they had those, but not a 317?
That's right. Not the 317 came along during that time, but the adjustable aspect of it just
I see.
Yeah.
Okay.
So there were clunky ways you could make a 7805 be whatever you wanted by changing its ground reference externally. So we would do what a 117 does, only manually.
Yeah.
Like put a 2 volt Xena diode or something.
Well, I learned this trick from a technician who ran a small business I worked for when I left high school. He put a diode in series with the ground
get the voltage drop
of a 7815 to get 16 volts out of it instead of 15.
Right. And a power diode is not 0.6 volts. We're trained to think that silicon diodes are 0.6. Most power diodes are actually rated closer to a volt 1, 1.1, or 1.2 when they're in actual usage.
Current. Yeah.
Current. Yeah. There's an actual IR drop across it. So now I knew somebody, they were making parts for what was called the Ensoniq. Do you remember the old Ensoniq synthesizers?
Oh yeah, they still make. You can still buy Ensoniq gear.
Well, they're old Commodore people that
really?
made the Ensoniqs. Yeah, the guy that did the Sid chick did the Ensoniq. If that tells you why Ensoniq is what it is.
That's why that's why they were so popular.
Yeah. Yeah, and it's literally the same group of guys, just moved further down the road. So I forgot why I was mentioning that, but that's kind of like some history there for you. So I am exhausted. It's been a long week. Oh man,
and
what a week.
We've been going for about an hour. Well, since we actually got it going, right?
You got it going for about an hour. That's right. We started early, and I actually had to reload Skype today just to make it work. XSplit keeps trying to update, which we know that'll break it. It's just horrible. So
it's time to wrap this up.
Yep.
Thanks everyone for joining us. And
how many people do we have right now?
Oh, I wasn't watching.
Doesn't matter. Does the 128 have any 7805s? No, I did one of the first switching power supplies in a consumer home computer.
17. There's 17 people right now.
Okay. So, all right, my friend. Well, it was great talking with you. Glad we got it working again. I look forward to a time when it just works, you know?
Yep.
So
it will. We'll get there.
All right. So, all right. Thanks, everybody, for being with us. That's it for now. It's Miller time on the East Coast. You got to work a couple hours longer, but we'll see you next week, my friend.
All right. See you then.